For the complex fractions, when we have pluses involved in here, it makes things a little bit trickier because we can't just figure out times and divide parts for this. So what we want to maybe do, there's lots of different things we can do, but in this case here, what I'm gonna do is I'm gonna get rid of that divide by a plus 1 here and here. And to do that, I can do this very easily because if I do the top and bottom by a plus 1, I'm not changing the value of the fraction, but it allows me to get rid of that divide. So I end up with a plus 1 times 1 minus, and the a plus 1's cancel out, so these cancel out, so I end up with minus 7 on the top. On the bottom then, the a plus 1's cancel, so I'm left with 4 times a plus 1. Oh, sorry, that's not true. I'm just left with 4. And then plus, the a plus 1 times 1 gives me the a plus 1 here. So then I can just combine like terms, so I end up with a minus 6 on top, a plus 5 on the bottom, and that's my simplified form of that fraction. So there are other ways we could do this. We could have got a common denominator and worked it out that way, but this way seems to be fairly straightforward, especially since the denominators match. Taking a look at g, we have a similar situation except the denominators don't match. But we can use a similar strategy in that if I want to get rid of the x plus 1, I'm going to multiply that by x plus 1, and I have to balance the fraction with another x plus 1 on the bottom. I want to get rid of that divide by x minus 1, so I'm going to multiply the bottom fraction by x minus 1, but I have to balance it with an x minus 1 up here. Now I just have to make sure I keep track of my factors. So the x plus 1's cancel, so I end up with 1, and then the x minus 1 doesn't cancel, so I end up with x minus 1 here. Plus, nothing cancels multiplying the 1, so I end up with x plus 1, x minus 1 here. Okay, that's the numerator of that fraction. And the denominator of this fraction, the x minus 1's cancel, so I end up with 1. Now I'm left with x plus 1 minus 2. And then nothing cancels here, so I end up with x plus 1, x minus 1. So now I just have the numerator and denominator. I can combine like terms and see what kind of factors I'm dealing with. So I end up with x minus 1 plus x squared minus 1. That's my numerator. In the denominator, I'm going to end up with x plus 1 minus, I have to be a bit careful here. This is going to be minus, in fact, I'm just going to use brackets. And then, so that's going to be negative 2x squared. Okay, so then working that out, I get x squared plus x minus 2 in the numerator. In the denominator, I end up with negative 2x squared plus x, and then that's going to be plus 2. So the denominator doesn't look like it's going to be factorable. So although the numerator is factorable, I'm going to leave it like that. In both cases, I really should state restrictions. So restrictions here are going to be a not equal to negative 1. And I also have a not equal to negative 5 as my restrictions. In this one, in the next one over here, I have x not equal to negative 1, positive 1. And then I also have this whole denominator can't be equal to 0, so I'm going to write that out. Negative 2x squared plus x plus 2 not equal to 0. Now I could solve that using quadratic formula and make sure, and I can get the actual value of that, but that's for now good enough.